a scientist does an experiment, they follow certain steps to make sure that the experiment will be fair and that it will test what they want it to test. So we talked about these steps, and they're called the scientific method. Another aspect is, how do they run an experiment? For example, if you're doing an experiment to test whether a certain fertilizer will make bean plants grow taller than other fertilizers, you want to make sure that your results are just from the fertilizer use and not some other factor. And those are called variables. So everything else has to stay the same except for the one thing you're changing, which would be the fertilizer. Same, and the things that we keep the same are called constants. And there's also an entire constant group. So maybe you're testing plants without fertilizer to plants that get fertilizers. And when we do experiments, it's a good idea to do multiple trials. That is, to do the same experiment lots and lots of times. When we do multiple trials of the same experiment, we can make sure our results are consistent and not altered by random events. And multiple trials can be done at one time. And if we're testing, say, a new fertilizer, we could test it on lots of individual plants at the same time. The other aspect that we've recently talked about in class are variables. And variables are the things that we can change in an experiment, either directly by manipulating them, or an indirect result that is the responding variable, or what we call the dependent variable. So we're going to do a lab now. Find out how much water the head side of a penny can hold. So our independent variable is the head side of the penny, and our dependent variable is the amount of water, and we're actually going to measure that. So what you're going to record in your notes, the trial number, so we'll have 5 different pennies, so you can call it just trial 1, trial 2, trial 3, trial 4, trial 5, and then what you're going to actually measure are the number of drops. So I'm going to ask you to watch the experiment that follows and to pause in order to count, to record the number of drops.
Okay, so we have 5 pennies, and all 5 pennies are heads up. Scientists use multiple trials or repeat experiments in order to increase the reliability of their outcomes. So penny number 1. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, oh, missed, 15, 16. Okay, so we're going to say at 15 it overflowed. Penny number 2. Do you think it's going to hold more than 15 or less than 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 drops. Penny number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 23 drops. So, first penny had about 15 drops on it, but I missed the penny on the 14th drop. So that kind of was like, was that a reliable outcome or not? And then on the second one, we had 16 drops. But on this third one, we had 23 drops. Okay, penny number 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. $15, $16, $17, $18, $19, $20, $21, $22, $23, $24, $25, $26, $27. Still hasn't gone off the penny yet. $28, $29, $29. So we have 15, 16, 23, 29, and now our last penny. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that one we got to 20 drops and it went off the penny.
So, but watch the experiment, record the number of drops as you watch. And then what we're going to do is we're going to take this data and we're going to talk about how it can be organized in different ways and what's the best way to show what we're trying to prove. We'll also talk about, are all pennies, like, is there one number that we can use because all pennies might be alike? So we'll talk about different ways to average our data as well. Great job, everybody. Thanks for watching.